Today, let's talk about conjoint analyses, and this is another way of testing multiple concepts at the same time. And if you go back to how we do value assessment, that is, how do we get customers' inputs and then find out if a concept, which is the idea that we're describing in words, figures, and so forth, whether it has any value or not, we could either check for people's attitude, which is how much they like or dislike something, which is what you have inside you, or behavior, what you display when you pick out a product, or you can talk about inferential or basically observation research and so forth. We won't talk about the last one. Let's talk about attitude and behavior. Oftentimes, when you like something, you're going to display consistent behavior to what your attitude is, which means that if you like something, you're going to buy it. If you dislike something, you're going to refrain from buying it. So, if you do capture attitude, you can very well say that uh, under certain circumstances, the same person's going to end up buying the product. And it's easiest for us to tap into attitudes rather than to get to behavior if we don't have a fully formed product. Or we can simulate a scenario where people can actually pay for money and so forth in order to test for behavior. In attitude, you can either ask people directly whether they like or dislike something, or you can basically ask for some amount, some preference or choice, and then infer whether their attitudes are liking or disliking, or whether there's certain parts of the product or concept that's driving their preferences in a particular way. And so the indirect or the decompositional method is the conjoint, and that's what we'll talk about. There are other methods too in terms of constrained compositional methods, and so that's a multi-attribute, which we'll not be talking about for this, just for this video. So let's talk about conjoint. Before we get into conjoint, let me tell you a few things on why conjoint is so important. Um, if you take a concept test, then you show one concept at a time and get purchase intent. Whereas in conjoint, the advantage is you can actually show multiple concepts. So let's assume you have 5 different versions of a tablet that you are thinking about launching. Then you could show all 5, which are defined by certain attributes, which are certain features of the particular product. And you could find out which ones are good. And I'm going to define for you 2 different terminologies that are particular to conjoint. The first one's an attribute and the second's level. So an attribute is the key features of a product. So if you think about a computer, you're talking in terms of hard disk. You're talking in terms of, let's say, the RAM or the memory that you can use. You can talk in terms of if it's a computer that is either in the PC form or in a laptop form. You're talking about screen size. You're probably talking in terms of the processor speed. Those are the attributes, what I defined for you. Now, each of those attributes, if you take processor speed, can come at different levels, which means that the processor could be in Intel in the past, it could be a 486, 586, and so forth, or it could be a Pentium 5, or it could be a much more recent version of the Intel chips. If you take hard disk space, the levels of that particular attribute could be, let's say, 120 GB or 240 GB, 500 GB, or 1 terabyte, right? So those would be 4 different levels of that attribute. Um, these are quantitative levels of an attribute. So if you talk in terms of 120 and 240, which means that you could form anything in between 120 and 240. So you could actually simulate and find out if people's preferences for 120 is X and people's preference for 240 is 2X. Then you can say if you had something in between, which is almost like a 180 GB, it would be about 1.5x. Okay, so you can simulate within levels for a quantitative attribute. But what if you had qualitative attributes? So levels of an attribute. So for example, what if you were offering an iPod in blue, green, and pink color? So those would be levels of an attribute that are more qualitative. So you can project within, but you can find out for each level of that attribute how important it is. So the way we're going to talk about is some of these attributes are measured in different, let's say these quantitative attributes, each one of those comes in different metrics. So if you're talking in terms of processor, you're talking in terms of speed. If you're talking in terms of hard disk, you're talking in terms of GBs. And for example, the qualitative, how do you define these? So you need a common metric that you can use to measure across these various levels of an attribute and the attributes themselves. And what we're going to use is what we're going to call a part worth. How much is this part worth to a consumer, which can be extracted out of people's preference. So if a person likes it to a particular degree and they indicate on a 5-point scale 5, then you can translate that 5 into what it translates to each one of those parts. So part of one particular level of an attribute, another part of an attribute, and then we'd use people's preference or liking of a product as the common metric whose parts can be distributed among the various different components that make a part of the product. Okay, so that's the intuition for conjoint. Let me just tell you why conjoint is probably the most important technique, or one of the most important techniques in market research, and especially in new product testing. There was a small little survey that was done about 5-6 years back among 58 of the industrial firms, which are part of the Fortune 500 firms. And they also asked a few market research firms, and they asked them for the familiarity and usage of various different market research techniques that companies employ. So for example, you could look at the assessments that you do internally, or you could look at direct surveys, focus groups, and so forth. While most people are familiar with focus groups, the usage was about 60% in the industrial firms and even among the market research firms. But if you look at conjoint, among the market research firms who can employ it very well, it's almost equivalent to what you would do with a focus group, a qualitative technique that you focus group that we are so comfortable with, that is just get 10 consumers into a room and ask them to talk about a new product, which we are so comfortable with, is almost used exactly to the same level as conjoint. Whereas industrial firms and firms that don't have the expertise use it to a limited extent, which is about 28% here, and hence are not able to leverage the benefits of conjoint in order to test new products. Okay, so my pitch to you is for you to learn conjoint and learn it well so that you can use it in your own companies and for any other ideas or new ventures that you're thinking about. Okay. So let's find out a few questions. So for example, I don't know if you know this, but the Courtyard from Marriott, the entire concept came from conjoint. The Baltimore Ravens, their logo was designed using conjoint. E-ZPass, which is the transit pass you use as you travel on the New Jersey Turnpike, was designed using conjoint. If you were to be specific, for example, within the Courtyard from Marriott, here's a question. Should we offer our business travelers more room space, or should we offer a fax machine? Which one would they trade off? Meaning, how would they trade off one for the other? Which one would be better, given that you can't offer everything? Because there's a budget constraint, and there's also a budget that you can expect the consumers to pay for, right? And for that particular price that they can pay for, how much can you charge? Here's another one that's more internal to the company, more engineering driven. Given a target cost for a product, should we enhance product reliability or its performance? Let's take an iPod, for example, and this was used by the MacBook Pro when they were designing. Should we go for a steel casing or should we go for an aluminum casing in order to increase people's preference? And how much more weightage would people give if we went for aluminum casing? While we talk about all these companies and these all these products in this fully formed form, most of these companies employs techniques like conjoint in order to find which way to go with the product development. So here's a typical question that P&G asked for disposable diapers, which is one of their more best-selling items. And we're talking about consumer products. Walmart, for example, one of their biggest selling items is the diapers. And so when P&G's question was, should we go in with and improve the absorbency and invest our money behind that and ask consumers to pay for that for an increased, better product on absorbency, or should we work on the elastic waistband and see how it fits the different kinds and shapes of the baby's hips? And should we work on those? Which one should we work on? And so that was a question that they used conjoint for, that before they even invested the resources, they got preferences elicited from moms, and they used that to then design the product. So let's dive into conjoint. Before that, let me tell you a few assumptions that conjoint makes, some of which are hard assumptions, but you can still get lots of inferences about people's preferences and how they decompose into the particular attributes and the levels within an attribute. So the first is that products can be defined by the individual attributes and levels, which means that if you have a product that can be defined by an attribute, then there's no way for you to find out if people say that they like the product to some particular degree, then what's driving the preference? Is it this attribute or the other attribute? If you're not predefined it, and if you don't make an assumption that these attributes are what contribute to preference of the product. So you could very well imagine a computer. If you think about just hard disk space and processor speed, and you ignore, let's say, the RAM, and you ignore the colors and the screen size and so forth, then your preference that you elicit, and then you're trying to parse it out over two attributes, doesn't make sense because people's preferences are driven by three other attributes. The second is that when you get people's overall preference, you can partition it across the attributes that make up part of the product, which means that you can decompose a total preference into parts of the preferences for the other product, the other parts of the product. Okay, so the two assumptions that we make. One is that you can define it by attributes and levels, and the second is overall preference can be divided between these attributes or levels. Here's an example that Campbell used for the soup. So they could come up with different versions of soup, but they went and thought about their R&D came up with and said, look, what we think is important for consumers are four different attributes. One is what kind of flavor we're going to offer in the soup. Second is how much calories are we going to put in the back of the soup can. Whether it's going to be salt-free, and that's going to take a little bit of processing as compared to no salt-freeness. And lastly, they also thought about including price. Price is a tricky attribute because oftentimes you think about price as one part of the equation, all the benefits on the other part of the equation, which means for all these benefits, how much price am I willing to pay? And so adding, if you will, the dependent and the independent variables makes it a little tricky, but it chose to talk about these soup cans as either $1.19 or $1.49. Okay, so four different attributes. And now let's take the first attribute, which is the flavor. Their idea was that they could come up with an onion flavor, or they could come up with a chicken noodle flavor, or a country vegetable flavor. And salt-freeness was yes and no. Calories was 80 calories, 100, 140. And so there are three levels of the flavor attribute, three levels of calories attribute, two levels of salt-freeness, and two levels of price. If you just consider the attributes per se and the levels that they have, a couple of attributes are quantitative attributes, that you have calories and price, and then a couple of them are qualitative attributes, which is flavor and salt-freeness. The second thing is, while flavors has onions, chicken noodles, and country vegetables, this is called a nominal attribute because it has different levels that you can compare and contrast between each of those levels. You just take it for what it is. Salt-freeness is a 0 versus 1, right? Either you have it or you don't. And so that's a different qualitative attribute, if you will. Okay? So four attributes. How many products or concepts can you make out of this? It's actually 3 into 3 into 2 into 2, which is 9 into 4, which is 36 different concepts. Here's one concept that they could make. They could make an onion flavor at 80 calories with salt-freeness, and they could price it at $1.19. Alternatively, they could make a chicken noodles at 80 calories with salt-freeness or $1.19, and so on and so forth. Okay. So if I were to describe each of those concepts, I could show a concept similar to this and say, if you're thinking about a soup, let's say the flavor of the soup is onions, the calories are about 80 calories that it offers, it's salt-free, the price is $1.19, it's going to come in a regular Campbell soup can. What's your rating of this on a 1 to 9 scale? Meaning, how much do you like this? How much would you consider this if you're purchasing this? Okay, so that would be one example of a concept that you would show. And assume that for one person, this is one person's response on the 36 different concepts that you could show. So if you showed the entire 36 concepts and you showed one after the other, and for the first one the person said my rating is 9, and for the last one, which is the 36 concept that he showed, the person's rating is 4, then you have preferences laid out. And now, what's driving the preference? So if you just look at the first two, that means that a person's rating has gone down from 9 to 8 because something has changed within the product. So the only thing that's changed within the product is price, which means that you increase price by 30 cents, it drops people's preference by 1. At least for this one person, it dropped preference by 1 percentage, right? 1 point on the rating scale. Now let's take the onion versus the chicken noodle. So if you were to average 1 to 12 of the ratings, and then if you compare the average the ratings of 13 to 25 or 24, then you can compare onions with chicken noodles, and say when you change, irrespective of whatever else changes within it, whether it was calories, salt freeness, or price, um, when you change chicken noodle, when you offer chicken flavor versus chicken noodle flavor versus onion flavor, the difference in preference was so much. And so that's the intuition with which conjoint works. And an output of conjoint looks typically like this. Let's say, and we're going to talk, like I told you before, we're going to talk in terms of part worths, which is how much a part worth, and we're going to talk in terms of how much utility a person gets from that particular attribute, or how much of preference it is, right? So we're going to use these interchangeably. So let's talk in terms of utility, right, which is a different version for how much a person likes for the product. So the utility coefficient that it calculates, that the computer calculates, and typically a computer software program like SPSS or something else, like JUMP, where you feed in the data that we had from the previous one, which was this. You have that, and then you feed it into this, will result in an output that will take the base level of one level of the attribute. So for example, flavor to chicken noodles is 0, and say how much more can you bump up people's attitude or utility if you go from chicken noodles to onions. And so the bump is basically 3.5, which means that you can increase on a common metric called utility, which is an abstract concept. You get about 3.5 more utility points when you go from chicken noodles to onions. When you go from calories, when you drop in calories from 140 to 80 calories, so you actually increase the utility only by 2.03. And price, if you increase the price, you're going to drop in utility by 0.63, or if you drop the price, you're going to increase utility by 0.67. Okay, sorry, it's 0.67. And so price is not that important if you think about it, at least for this one person's response, because as you increase price, it didn't impact utility as much as offering the kind of flavor that the person wanted. Okay, and so now we can compare between flavor and price by saying flavor, for example, is 4 times more important because you can go from 0 to 3.66 if you went from chicken noodles to country vegetables, as compared to price by dropping price. So our typical notion that price is the most important attribute doesn't hold, at least in this context. But how do we know? Well, this is the first output that's provided by conjoint. And you can show it in this form, which is in the number form, or you could show it in the graphical form, which would look like this. And so an output from conjoint would look like what's a part worth, and we talked about utility and part worth. So when we talk about utility, it's for the level for the attribute, and part worth is for the levels of the attribute. So how much is this part or this level worth in terms of utility points? So onions about 3.5, chicken noodles is 0, country vegetables 3.66, and the plot, the line graph, shows you what that is. And so if you wanted the best product that you wanted to introduce, you would take the highest ones, correct? So that means that you would take the ones that impact your utility the highest, or the customer's utility the highest. In this case, it would be a country vegetable at 80 calories with salt-free and at $1.19. We don't know if that's possible. We don't know if this is something intuitive. We could have guessed it. For example, price, calories, and salt-freeness. We know that it has to follow these forms. But the question is, we didn't know when we started this that flavor was the most important and price the least important. And so this is the first output that you get in terms of the part words, and you can either show it in the quantitative form or you can see it in the graphical form. The second output that you get from conjoint is how much are these attributes per se, how much weightage do people, that particular person, when they made the preferences, they allocated across the 36 concepts, seem to be driven 8% by price and 45% by flavors, with about 20 odd percentage for salt freeness and for calories. Okay. What's the black box? How was these parts words calculated? How were these importances, which are the two outputs they provide, how were they calculated and how were they determined? Okay. And if you think about, all we saw was the person responding to these 36 concepts, and based on that we tried to infer how much was this part worth for the particular individual, or how much were they reacting to each one of those attribute changes. Okay, so how did the computer know what to change or what to allocate in terms of utility points for when one level of an attribute change for another. Okay, so I'll just give you a basic model of what this will look like. A conjoint model goes with, because it's a decompositional model, it goes as, if you take the total utility that a person gets derives from a particular product concept, then it's the sum of all the parts that they see. And the parts are, let's assume the parts are, just to be abstract, A1, A2, A3, etc. Then the person gets a small little utility level from A1, which we'll call as UA1, and another one from A2, which we'll call UA2, and so forth. And the sum of that leads to a total big U, or a capital U, and so that's the total utility that a person can derive for the product. Let's take a stylized, simple example. Okay, and hopefully this will convey to you what the idea is, and the note that you have in your readings will have a slightly different other example, but will again have you repeat the same kind of calculation that I'm going through right now. So let's take the notebook computer example. Let's assume for a minute that there are only three attributes that are important. We know that these are the three most important, and there's nothing else that's important. Okay, the three important things are processor speed, hard drive, and memory. And processor speed, which is one attribute, can come in two levels of the attribute, which is 1.5 gigahertz or 2.5 gigahertz. Hard drive can be at 120 GB or 160 GB. Memory can be at 1 GB or 2 GB. And obviously times have changed, and you might think, what's 120 GB, what's 160 GB? It's actually 500 GB and 1 terabyte, right? But in this stylized context, the same learning that you get from this can be applied to a 500 GB and a 1 terabyte kind of context. So if you think about how many products can be introduced in this product space, there can be 8 products, because you can make 1.5 gigahertz, 120 GB, 1 GB memory. That could be one product. Or you could go with processor at 1.5 gigahertz, hard drive at 160, and a memory at 2 GB. And that would be a different product per se. And so that could be a second product, and so forth. And so you could create 2 by 2 into 2 into 2, which are the two levels of the attribute 1, 2 levels of attribute 2, and 2 levels of attribute 3. You multiply those, and you get about 8 different products that you can make. Let me show you how these would look. So it probably look like this. So you could show a person, ask them to fill out this matrix, for example. In that, the row, for example, are the processor, different processor levels. The columns split by hard drive, 120 GB hard drive with 1 GB memory or 4 GB memory, and the 160 GB hard drive by 1 GB memory or 2 GB memory. So there's 8 different products they can. Let's assume for a minute that one person responds, typical to what we did with the Campbell's soups, and we ask, instead of people rating it, we just show them these 8 different sheets of paper with these combinations. We ask them to just rank order them. Just basically take these and just put them into a pile, and in the pile, the top ones indicate which ones you like the most, the bottom ones the ones that you indicate like the worst, and you just rank order them. It's not too different from what Dell does. So Dell, for example, has its various configurations available on its website, and people go there and they look for the number of clicks instead of, and the more number of clicks, the more people prefer it. Could be one indication of what it does. Okay, and we get this ranking, and the ranking looks like this. And so this person's response is the concept that he showed the last, which is 2.5 gigahertz, 160 GB with 2 GB memory, was the one that they preferred the most for this person's preference. Let's say Joe, and Joe's preference was concept 8. And Joe preferred concept 1 the least, which was 1.5 gigahertz, 120 GB, 1 GB, which seems intuitive, in the sense that if you offer low of each attribute, that seems to be preferred the least, and the high of each attribute, that seems to be preferred the most. But what's more interesting is what's happening in between, when you're forcing Joe to make a trade-off between processor and hard drive. Which one is the person willing to give up first? So let's say, what's the second most preferred? 2.5 gigahertz, 160 GB, and 1 GB, which means that the person's held on to processor and hard drive and is unwilling to give that up, but is willing to give up memory. So which means that these two seem to be much more important to Joe as compared to memory. So that's an intuition. How does the computer get this intuition and calculate part words? The computer, and I'm just going to give you the intuition for this rather than provide you with the math behind this. The intuition behind this is it runs regressions. It runs dummy variable regressions. And what's a regression? Regression is an equation that you form based on one dependent variable with multiple independent variables. So for example, sales as a function of advertising, as a function of the amount of new products that you've introduced, the amount of salespeople that you have. So higher the advertising, higher the sales. Higher the new products you have, higher the sales, and so forth. So each one of these makes sales go up. But for example, advertising contributes to much more than new products, so it means its coefficient is going to be higher than the coefficient for new products. So that's, if you will, a 1 minute version of what a regression is. Now, what it does in this is it assumes utility. That means it reiterates and it puts numbers in to calculate what numbers would recreate this rank order. So it tries to create a rating from a ranking. So for example, if a person probably ranked at 1, maybe the rating that I should give, or I tried, is 8, which means if I give it 8 points, maybe that's what's contributing the first rank. And the 8th rank is actually 1 point. So it makes this mapping, and it internally tries these numbers out that exactly maps onto the ranking that the person's done. And once it runs these ratings, it also tries to minimize the error, which means that a person makes a preference 3, preference 4, right, and the combination of those attributes gives the total utility that it should. Okay, so it assumes assume that the computer has calculated these utilities, and then what it does is it tries to estimate how much each of these parts worth. And how it does is it runs a regression. It takes utility as a dependent variable on the one side, and then it takes the 3 components, which is where we varied it as processors, hard drive, and memory, and runs a regression and tries to find what those coefficients are. And those coefficients are B1, B2, and B3. There's also a standard, it's called an intercept, which means that if you don't offer any of these, still the person gets some utility from just having a box called a computer. Okay, so that's A for you. Okay, the intuition is, what it does is it takes the total utility that it does through those iterations, and it calculates as a U, and it puts that and says, for the first concept, when everything was set at 0, so because there are only 2 levels of the attribute, each of those, processor, for example, is a low and a high, hard drive was a low and a high, memory was low and a high, what it does is it assumes the low is 0 and the high is 1, and says, now if I were to take this equation and put the zeros for the ones wherever we offered low and 1 for the where we offered high, then for the first concept, U1 is a function of A, which is what the base utility the person gets, and everything else was set at the lowest level, so it's zeros. So which means that the lowest version, or the 8th concept, or the last concept that the person preferred, offers a base utility, and that's A. So whatever the computer calculates all goes towards the intercept A. And then what it calculates for the next version, when you just basically bump up one of those attributes as 1 and the other one's a 0, then A plus B1 into 1, and the rest of it drop out, is the second utility that you get, U2, how much the computer calculated. And so you can extract out A, B1, B2, B3 by subtracting the total utilities that was calculated. So A is equal to U1 equal to 1, B is equal to U2 minus U1, which means that if you go back to the previous slide and look at it, U2 was calculated as 5 and U1 is 1. Then basically B1 is 4 and B2 is 2 and B3 is 1. And we know for a fact that B1, B2, B3 are the importance of each of those attributes, which means B1 reflects how much weightage the person puts on processor. B2 reflects the weightage the person puts on hard drive, and B3 on memory. And so for this particular person, and you could basically go back and forecast, so you could calculate based on 4 and calculate and forecast it for another 4 utilities, because people have provided responses on 8 different attributes. There are only 3 unknowns, and you could minimize the error. And so that's where it goes back and checks those numbers again and again, but trying to minimize the error. So how do we calculate what's important? So we know that basically the computer does these iterations and then calculates these numbers, but then how does it get the importance? What it does is it takes the processor weightage by the total weightage, in this case B1 as a function of B1 plus B2, B3, and says 4 by 7. So maybe this person's responses are driven 57% by processor. Hard drive is B2 by B1 plus B2, B3, 2 by 7, so 29%. And so this adds up to 100%, 57 plus 29 plus 14, or round off errors. And so the majority, so you can find out one person's preference order, correct? And we can find out what happens to people's across, right? Meaning instead of taking one person, if you went across and asked 10 people what are their preferences and try to find out if there are segments within. There are some of these people seem to be similar to others, so seem to be similar to themselves but different from others. And so this is one segment versus another segment, and try and see are these preferences combining together based in one segment. So here's one example. Let's say you went to 10 people and you found out the importance. This is conjoint. You ran individual conjoint based on the preference order, and you put these together and you sat down with a sheet of paper. Then if you look at this, seems like there are a set of people that seem to have the processor as the most important. For example, customer 1, maybe customer 3, and customer 9. And customer 9 has a huge preference for processor as compared to customer 1 and 3. And so should they be put in the same segment, or are they two different segments? Something to think about. On similar basis, you could think about customer 4, customer 5, and possibly customer 7 have a huge preference for memory. So that you can find out, apart from conjoint helping you with what are part words and what is utility, if you did this across people, you could find out if there are segments of people that have similar part words. And that's important to find out which is the largest segment, because you can't make a product for every segment. And so you can find out which segment are we going to go after and what's the product that we're going to offer for that particular segment. Okay. And some of the bases, the preferences, some of the descriptors you could throw in are age, income, and so forth, and find out which is driving the preference. So for the Campbell's soup, let's go back to the first example. What they probably did was they calculated the utility and broke it down into the subcomponents, and the final output from the computer looked like this, which means that for the flavor, the utility or the part worth was 3.5. The chicken noodles, that part was worth 0 in terms of utility points. Country vegetables was 3.66, and so forth. Okay, and so what's the most important attribute? The one that offers you the highest from the low to the high, highest utility increase. So from 0 to 3.66 is the highest, and so that's why flavor is the most important. Whereas price 0 to 0.67 is not as high. Who knows if you had garbage in, garbage out. So what you throw in is what the computer is calculating. What if you change the price from, let's say, 1.49 to 2 cents? Maybe the preference order would have been very high for price and lower for flavor, calories, and so forth. So what you throw in is what you get. So it's important to think about these levels of the attribute before you collect the data and run the conjoint. So that's the first part. So you can find out what these parts are worth, and using these parts you can find out which is the most important product to make. The second thing that you can do with conjoint is you can simulate, because if you think about the combination of these attributes, you can simulate for all the combinations, which means the 36 products. Maybe all 36 are not available in the market right now, only 3 are available, right? So you can simulate what happens if a fourth one was introduced in the market. And then I'm just going to provide you the motivation for this. Let's assume you've done the market research of those 8 different concepts for the processor, speed, hard drive, and memory, but only 2 of those products exist right now. And there's 2 products I'm going to call brand A and brand B. And the configuration that these 2 brands have that are in the market is brand A is 2.5 gigahertz, 120 GB and 2 GB. And brand B is 2.5 gigahertz, 160 GB and 1 GB. Now, what's the likely market share that a new brand can get if it had the configuration of 1.5 gigahertz, 160 GB and 2 GB? Okay, so that's what we want to simulate, knowing people's preferences. So what share will it get? Where will it get this share from? So again, an intuition for this is if you did the conjoint and you collected the preferences from people, and then you sat back and thought, what's the person A1, what's the person 2, what's the person 3, what's the person 4, up to 10 likely to do in the old context when there were only 2 brands, and the new context when there's 3 brands, A, B, and new. So let's take how much the total utility they get from brand 1 and brand 2 based on what they've told on the 8 different concepts that we've shown. We already know, for example, for customer 1, based on a discussion before, their part words for B1, B2, and B3, which were for the processor, speed, hard drive, and their memory, was 2, 4, and 1. And the base utility they get from just a computer, which is A, is 1. And if you add that based on what part worth, what levels we pegged A at, which was having 2.5 gigahertz and so forth, if you add it, then A probably provides that particular customer only 4 utility points just based on their preferences, whereas B offers 7 utility points, which means if these were the only 2 products that were available, then customer 1 would probably choose B over A. But now if you introduce a new product, that offers you 6 utility points for that particular customer, and so they're still going to retain B, because what we're going to believe is that people, what their preferences are, what they like, is what they're going to choose ultimately. But there could be in real life there could be other things that could influence. For example, some product could be discounted, another product could be much more available than another product, right? And so forth. But let's assume within the stylized context what's going to happen. Customer 2, maybe if you combine it, say A offers 7 points, B offers 6 points, probably A is going to be more preferred. The new one offers only 3 points, so they're still going to stick to A. And so if you take these and you take the last two columns that I have, so customer 1's probably with the new brand is not going to change, still going to choose B. Customer 2 is still going to choose A. Customer 3 is going to choose B. But here's the switch. Customer 4 is going to switch from A to the new, because the new with the combination offers you much more utility than what A offers. And if you think about what the market share the new brand is going to get, is they're going to get 3 out of the 3 customers out of the 10 customers, which means it's going to get 30% market share. And who's it going to get from? So two of A's are going to switch, which means that A's market share is going to go down from 40 to 20%. B's market share is going to go down from 60 to 50% because one person switched. And so you can find out not only how much market share you can get, but you can also find out where you're getting it from. And I think that's the second where you can run these simulations of the what-if analyses, and that's if you will, what most companies do. Nike, for example, uses it in their market research. Most of the cell phone manufacturers use it in terms of, should I offer 5 megapixels or should I offer 8 megapixels? And here was one. Which we ran with students here at the University of Arizona. One of the student teams actually had a projector that they wanted to put on their cell phone, which was a Pico projector, which means that if you had a Pico projector on it, you could actually project what you're speaking. And so if you had a small little video, you could project it on the screen, and you can imagine what how a salesperson would use it. This was before the tablets came in, where you could show that particular big screen. And so their thinking was, how much utility does a Pico projector offer as compared to megapixels that you can have, having multiple SIM cards that you can have on your cell phone, or for example having front-facing, back-facing cameras and so forth. And so they found that the Pico utility was not as high as the other ones, and so they refrained from making the product based on the conjoint. Who knows, in the future the Pico projector might surface in a different form factor, and in that form factor might be much more might offer much more utility than the other smaller things that they offer right now in terms of ease of use and whatnot. Okay, that's the conjoint simulation. So how do we get these responses? So I showed you two things. One was actually rating of the concepts, another one actually ranking of the concepts. There are other different ways of getting it. So for example, you could get people to rate on a 0 to 100 scale. You could just ask people, pick one, and then if you did it among 100 people, you could find out which one has picked the most. Dell uses this in the computers. For example, the website, they find the computer that has picked the most. Okay. Here's a typical complex conjoint study that you would do. So the first stage that you do is you design the conjoint study, which means that you would select the attributes, and then for each of those attributes you select the levels of this attribute. And based on those, you would see if all of those made sense. If you combine those levels of the attribute, if it actually looked like a product. Then you would make these into concepts and decide how you're going to collect the data. Are you going to ask for responses in terms of rating, ranking, preference? And then you would collect a data collection method, which is how are you going to reach these customers? Are you going to meet them in the mall? Are you going to send them an internet survey? And then once you do that, you would collect the data. Then you come back to the computer and find out the program that you're going to use and the computational method. There are a few which I've not touched upon, different computational methods that you can use that minimize the error in different forms and calculate these part words. And once you design that, and once you get the part words, then you would start finding out, based on the analyses, are there segments of customers that you're looking at? Can we run some simulations of this particular product combination that we showed actually looks like Sony's product. The other one looks like Samsung's product. Can we look at these and find out how much market share this has and compare it to real life? And then you can set other kinds of choice rules in terms of customers. If they have equal preference, it's going to go one for the one that's cheaper and so forth. Okay. Just some pointers to you. Attributes that you have, if you choose attributes, make it so that it's determinant, which means that people will have some idea that this is what it is. It can be easily measured so people can react to it. It's something that the company, once you get the feedback, is something that they can change, the company can use, because without that, what's the use of actually changing attributes? It also offers you a realistic scenario because already it's a stylized context. You're showing them a concept in the written form actually compared to what people are making product choices. So you want it to be as realistic as you can. And you want to also be able to find the levels of an attribute so that people can provide some pointers in terms of the preference ordering. So what happens if you, for example, offer 120 GB, 125 GB, and 130 GB? People's preferences are not as fine-tuned that they can make a difference between these. What's compensatory is the last one, is that if people trade off on one attribute, they can get some utility from another attribute. That means if I trade off on processor, I can get some more utility, or I can derive some utility from hard disk space. You want to make sure that all of these are together form a choice set, and there's not something that you've not considered, which is the major part of the product. And you also don't want to build redundancies, or basically that if you have the same levels of an attribute, doesn't make any sense. Okay. How many levels for an attribute? You want to make sure that they're meaningful, so you want to choose fewer levels if you can, because all these can add up pretty quickly. So if you have 2 levels of an attribute, then two of 3 attributes, then you have 8 different concepts. If you had 3 levels of the same attribute for 3 different concepts, you would have 3 power 4, 81 different concepts that people. And you can imagine that between 16 concepts that a person has to do versus 81 concepts, the amount of time and the fatigue that you're going to have. And you also want to avoid absurd configurations. For example, you can have the cheapest product at the highest of the various attributes. You also want to make sure that that when you go from, you want to minimize the number of levels where it's very marginal in terms of the benefits that you can get. What data collection methods should you use? Should you use a full profile, which means that one person responds in 81, or should 81 people respond in one concept each? Or is there some media in between? So that's called a fractional factorial design, not for today, but something that you can read up on your own. A very common method that's used is called a pairwise, which means that you show 2 concepts at the same time and ask for which one's preferred more as a combination, and there's a way that you can. But it lacks realism, and sometimes there could be inconsistent responses, because when you show 2 preferences, people seem to show one, but if you show the same 2 in a different form, consumers can't choose between them. So that's it for conjoint for today. Hopefully you'll be able to learn much more through the Node 2, and hopefully use it in your projects.